The rules as such are quite simple. So depending on the factor of the denominator, depending on the factor that you have in the denominator, you have to choose the corresponding partial fraction. For example, if you have a linear factor in the denominator x minus a, corresponding to this linear factor, you choose a partial fraction, some unknown by that denominator, by that linear fraction. For example, if you have a fraction, a factor of the form x minus a whole square, we have a factor of the form x minus a whole square. So corresponding to this x minus a whole square, so you have to take two partial fractions, one which looks like a by x minus a, another which looks like b by x minus a whole square. In the previous example, you can see that corresponding to x minus a whole square, we have taken only one of these. That is why the process have not worked. Corresponding to x minus a whole square, you have to write some number by x minus a as well as say number b by x minus a whole square. For example, if you have x minus a whole cube, we need three partial fractions, a by x minus a plus b by x minus a whole square plus c by x minus a whole cube. And if you have sometimes a quadratic factor which is non-factorizable, that is which you cannot factorize further. So correspond to this denominator, you need to put ax plus b by x square plus bx plus c. So in the numerator, you have to take a linear corresponding to this quadratic. Corresponding to a linear factor, you have to take constants which are 0-degree polynomials. Corresponding to a quadratic denominator, you need to take a linear factor in the numerator. So if you understand all this partial fractions, so you can split a given proper rational expression into partial fractions very easily. So let us use these rules and see how these can be applied.